Hi, welcome to the video tutorial for the 11th Let's Think secondary science lesson, which we've called What's Going On Inside the Wires. Now, the preparation for this lesson depends on how familiar your students are with working with circuits. It might be that as part of the start of the lesson, before you show them what to do, you show them a circuit. Because the starting illustration gets them talking about the fact that longer wires, the bulbs are dimmer. So something must be going on, less currents flowing. And this is a good example of why these are thinking lessons and not content lessons. What we're using this is to touch upon inverse proportion and build upon the knowledge they have from the seesaw lesson that they've just done. So here we could talk about resistance and all the other things that are associated with understanding circuits, but we're not going to. We want the students to start thinking about inverse proportion and quantifying that using the numbers they get from this experiment. And there are as with the seesaw activity, there are two activities you can do, but many classes will only get through the first one. What the students need to do here, so how you set it up, is up to you and your technician, the resource you've got, is the students to be able to measure easily the current at different specified lengths of wire from 40 all the way up to 160. So in the past I have just stretched out, given them a length of wire and they stretched it out. I know some schools use this where they wind a set length of wire around a lolly stick and the students measure the current at either end. This is how I prefer, so the students can see it getting longer physically, but also then measure the current. You will need to consult with your technician about the voltage to use and the thickness of wire that they've chosen so that the students don't hurt themselves with the wire heating up. But the challenge here is the results aren't very tidy, and the whole class need to collect them, and the students need to take, and I've had in this activity, one of the things when they've collected their results I get the pupils to do is walk around and look at people's data, because we're looking at approximations here, because we want them to spot the halves and the quarters and the thirds, because you want them to realise by the end that if you make the wire 10 times longer, the current is 10 times smaller. So there's a lot of fractions involved here, and the students will need to approach that through their results. And it might be worth that people writing their results on the board so they can start to see how we're moving on from, as it gets longer the current gets less, to start to quantify it. And in the first activity, the worksheet guides them through that. So measure the current at different lengths and write it down. Then it starts to get them predict. So if you know the current at 70 centimeters, what might it be at 210? So the first discussion is a summary and the students' thoughts about the thinking that's going on in this sheet. There is an extension which involves thicker wire. Now, I know some schools have set it up like this, so this is an easy way of providing an extension activity. You just have thicker constant wire round around a lolly stick at specified lengths. So this is 30 centimeters and thicker, and so you could have several of these ready for the students who are able to get their data, so they can fully engage in this challenge, which is the lights are dimmer. What can you do to make them brighter? You can shorten the wire or actually make it thicker. So there's lots to discuss here. So there are no challenging work cards because the results that you get from this experiment are challenging enough. And indeed, the final work card, we're getting them to try and sum up inverse proportion, and the fact that it might be all around them, and the different ways that you can say this, and the different ways that they will experience it. If you've got time, it is actually quite interesting plotting the graph of the data that you get as you increase the length of the wire and measure the current. There's a lot of light bulb moments in this lesson where the students start to spot the patterns, and it all comes from what they hear and see their peers doing. I mean, it's a lovely feeling in the lessons when a student suddenly spots that something's halved but the other thing's doubled. And they can approach that from lots of different ways, but it can be a really lovely time as they start to agree with each other and say, yeah, I can see that too. Oh, and if you make it 3 times longer, oh, it thirds. And that gets over the barrier of the numbers, because the numbers are approximations and they're not tidy, but the students really grasp it and run with it if you use their data and give them enough time to talk and share their insights and not go over this. So the plenary session here is very, very important for them to start to spot the pattern, really run with it, and then apply it into other areas.